Hi friends, so now we are dealing with this orthogonality. Okay, orthogonality is a feature that can be used in combination regardless of other features. Okay, so you know that there is something called an assignment. Okay, an assignment what I will be writing is I can just write a equal to I can say a equal to 5. So the value 5 will be copied to a. Okay, and likewise I can write a equal to d where the value of d is copied to a. Okay, so whatever the value in D, it can be copied to A. So this is a normal assignment operation. Okay, but here in this language that is Alcode 68, you can see that uh, it is done in combination. Okay, so here the assignment is done in combination with this if statement. Okay, likewise here an assignment is done in combination with a function, with a block. Okay, like begin f of b, g of c, and okay. So let's see what happens. Okay, so in this statement we can see that a equal to if b less than c, then d else e. So what happens here? First, this condition will be evaluated. That is, if b less than c. The condition is true. This will return d. Okay, if the condition is true, this will return d. That means the value of a will be d. This statement will be rewritten as a equal to d if the condition is true. If it is true. If the condition is false, then this block will return e. That is, this step will be same as a equal to e. So the value of e will be copied to okay. So the value of e will be copied to a. The condition is false, and the value of d it will be copied to a if the condition is true. Clear? So in this assignment is combined with if operation, if condition. Likewise, in this step, this is a function. Okay, begin f of b and g of c. Here, what happens is here in this function, g of c is returned. Okay, g of c is returned, and whatever this value that comes out of this function g of c, it will be stored in a. Okay, in C we will be similarly will be writing a equal to fact of 5. And this what happens is factorial of 5 will be evaluated and the value evaluated is stored in A. Okay, but this is different from this one in the sense that here we are defining a function. Here we are defining function inside the to the right side of the assignment operator. Okay, we are just defining a function. We are defining a body of the function here. Okay, so if I'm writing begin f of p, g of c, and what happens is a equal to, so this function will get executed and the value of g of c, it will be copied to a. Okay, so in this we can see that the assignment operation is done in combination with either the if statement or with the function. Okay, this property is called the orthogonality. Okay, and here we can see that uh, listen here. Okay, here we can see that in this in C program we can see that a equal to b is a conditional operation. It will check whether a is equal to b or the value of a is same as b, and a equal to b. What it does is it is an assignment operation. Okay, it is an assignment operation. Okay, if a equal to b, what happens is whatever the value of b, it will be copied to a. In a equal to b, it will check whether the value of a is equal to value of b. Okay, and you have to understand that in in C program there is no Boolean data type. In C language there is no Boolean data type. That is, If I am writing a condition like A equal to B, if I am writing a condition like A equal to B, it will return a zero value if the condition is false and a non-zero value if the condition is true. Okay, if the value of the condition, if the condition is false, then it will return a zero value, and if the condition is true, it will return a non-zero value. Okay, so what happens is if A equal to B, what happens if the condition is true, there will be a non-zero value. So the condition will be like if in bracket there will be some non-zero value. Okay, if the value A equal to B is false, then in C program we will be having if zero. If zero means the condition is false. If non-zero means the condition is true. Clear? So if non-zero, it will enter to the block. If zero, it will not enter to the block. Clear? Okay. And likewise, so this problem will lead to an orthogonality in C program. Okay. So if I am writing like A equal to B, what happens? If I am writing if A equal to B, whatever the value of B, it will be copied to A. Okay. Clear, right? If I am writing A equal to B, what happens is whatever the value of B, it will be copied to A. And if the value of this A, if the value of A, that means it is the same as the value of B. The value of A is not zero. The value of A is not zero. Then this will take it as a true condition. If the value of A or B, okay, you can know that because the value of B is copied to A, so the value of A and B will be same. So if the value of A, okay, if the value of A is zero, it will take as the condition is false. If the value of A is not zero, the value of A is not zero, then the condition will be true and it will enter to the block. Clear? That is okay. Before this step, let the value of B will be let the value of B let it be 5. Okay, before the starting of this step, let the value of B let it be 5. Okay. So if I am writing if A equal to B, if I am writing if A equal to B, if A equal to B, what it means? A equal to B means value of B will be copied to A. So you know that the value of A will be also 5. Here the value of A will be 5. If in bracket it is like if 5. Okay, so the compiler will just have a doubt. It will just misunderstand as like this. So if in bracket it is a non-zero value. So here also we can see that if in bracket it is 5. Since it is a non-zero value, it will term it as the condition is true and it will move to the block. So whatever the statements written inside the block will get executed. Clear? And before this execution, let the value of B let it be 0. Let the value of B let it be 0. So the value of B is 0. So if I am writing A equal to B, then the value of A will be 0. Okay, so the value of A will be 0. So this condition becomes if the value of A is 0. So if 0, that means it is similar that the boolean to false. Okay, so this is similar to that condition in which the condition is false. So if 0, that means the condition is false. So this will be similar to this one. So since the condition is false, it will not enter to the block, it will go to the next step. Okay, so this is the orthogonality assignment is used together with this thing. Okay, so this is an example for orthogonality in C program. Clear? Next one is combinational assignment. Combinational assignment means uh, here you can see that two things comes, that is increment and decrement operations. Like a plus a, pre-increment and post-increment, likewise a minus minus and minus minus a. Okay, whatever things that come in combination with an assignment. Okay, that comes as combinational assignment. A plus plus, you know that it is same as a equal to a plus 1. Okay, that is a shorthand representation. Likewise, there are some more shorthand representation like instead of a equal to a plus 5, I can write it as a plus equal to 5. So this is also a shorthand representation. Okay, so in combination assignment, what will come as increment decrement operators, both pre and post order increment decrement operators, and also it includes the shorthand representations. Okay, so no need to explain much about this, just to understand what do we mean by combination assignment. So if you are asked to write about a combination assignment, you have to write about the increment decrement operators, both pre and post increment decrement operators, and also you have to write about the shorthand representations. Next is a multi-way assignment. Okay, it is generally seen in Python program. Multi-way assignment. Multi-way assignment is that if I am writing like this, a comma b equal to c comma d. If I am writing like this, what happens is the value of c will be copied to a, and the value of d will be copied to b. Okay, in single step, I am using multiple assignment. Okay, in single step, I am giving a multiple assignment. So that is the multi-way assignment. Okay. So if I in Python, if I need to swap two numbers, I need to write like this: a comma b equal to b comma a. So whatever the value of b will be copied to a, and whatever the value of a it will be copied to b. That means it will get swapped. Okay. So this is called the multi-way assignment. The previous one was a combinational assignment, and this is the multi-way assignment. Okay. Now there is something called an ordering of expressions. Okay, you know about the ordering of operators. Okay, ordering of operators. Ordering of operators is basically based on precedence of the operator. Okay, that is, if I'm writing a plus b into c, you know, you know that since the precedence of star is greater than plus, first the b star c or b into c, b multiplied by c will be executed first. Only after that the value of a will be added to this result. Okay, so this will be similar as a plus first b multiplied by c. So first the b will be multiplied with the c, and the result will be added up with the a. Okay, so that is the order of operators, and it is basically based on precedence of the operator. Okay, now we are dealing with the ordering of expressions. Okay, order of expressions. Okay, uh, actually this is a dilemma. Okay, you don't have some perfect conclusion which does first or which does later. Okay, it is just a dilemma which will be simplified based on languages. In some languages, functions will get executed first. In some languages, the other get executed first. Okay, so just will say, okay, so this is if I'm saying about sequencing, I will be saying about control flow later, and in sequencing, I will be saying about this side effect. Okay, so anyway, I will just explain what is the ordering of expression. Okay, so let there be an expression like this: a minus f of b minus c into d, c multiplied by d. Okay, so let there be an expression like this. Okay, so um, there is a confusion. There is a confusion. Uh, the confusion is that whether c multiplied by d is evaluated first. Whether this c multiplied by d is evaluated first, or function f of b is evaluated first. there is a dilemma. Okay, which will be evaluated first. If this is another operator, if I am writing if this is a plus d, if the function is like a minus, instead of f of b, if I am writing b into 2 minus c star d, you know that b star 2 or b star 2 will be executed first because both the precedents are same and the execution is from left to right. Okay, so b multiplied by 2 will be executed first. But since it is not so, and here instead of this it is a function f of b, there will be a dilemma like which should be executed first. Either f of b should be executed first or c should be executed first. There will be a dilemma. Okay. In this, the dilemma may not cause much problem. In this, the dilemma may not cause a problem. Okay. Let the expression, I'm just changing this expression and let the expression be a minus f of c minus c star d. Okay. So let the expression be like this. A minus f of c minus c star d. Okay, so let the expression be like this: a minus f of c minus c star d. So a minus f of c minus c star d, and let the function of f of c. Okay, so c is an argument, and let this function, understand? Let this function is a function which do change the value of an argument. So in this function, in somewhere it changes the value of c. Might be because it is called by reference. Let it be a called by reference function. Okay, so called by reference function, what happens is whatever the value changes in the arguments will be reflected, right? Okay, whatever the changes. So let it this be a something like a called by reference type. So since this is a called by reference type, what if I am writing a set like c equal to a plus d, a plus b, if I am writing it. So what happens? The value of c will be changed. Okay, so f of c is a function which changes the value of c. F of c is a function which changes the value of c. Okay, so if this is an expression, then the order do matters. Okay, the order do matter. How it matters? Okay, let the initial value of c be 5. Okay, let the initial value of c be 5. Okay, so this is before execution of f of c. The value of c is 5. Okay, and after execution of f of c, let the value of c be 3. Okay, so before execution of f of c, the value of c is 5, and after execution of f of c, the value of c is 3. So this is 3. Okay, this is 3. Okay, let it be so. So what happens if I am just evaluating this one? Okay, so let the value of a it be 1, and let the value of b let it be 7. Okay, so if I am evaluating f of c first, if I am evaluating f of c first, okay, f of c first. So if I am evaluating f of c first, and let the f of c do return the value of c. Let f of c return the value of c. Okay, so f of c is a function which changes the value of c and also returns c. Okay, so this evaluation will be like if I am executing f of c first, what happens? The expression will be like a, that is 1 minus f of c is f of c will return c, so the value of c after execution of f of c is 3. Okay, since the f of c is already executed, the value of c is 3, so I am writing 3 into the value of d is 7. This will be the value of the expression if I am executing f of c first. If I am executing f of c later, that is only after c into d, if I am executing f of c, the operation will be like a minus c into d is 5 into 7. That value of c is 5 into 7. Okay, so we are executing this, or we are evaluating this before evaluating f of c. So the value of c before evaluating f of c is 5. So 5 into 7. And f of c is, after executing, the c will get changed and the same value will be returned. So it will be like 3 minus. So the value of a is 1. So it is 1 minus 3 minus 5 into 7. Okay, the first, if I have executed f of c first, there is output will be like this: 3 into 7, that is 21. Okay, 1 minus 3, that is minus 2, minus 21, that is minus 23. The value is minus 23 if I am executing f of c first. Okay, and if I am executing f of c later, then the value will be minus 35 minus 2, that is minus 37. Okay, so there is a difference in the result. So it is important for the compiler to go for ordering of expressions also. Okay, so it do have two parts, that is side effect. Side effect is f may change b or c. Now here I say that f is changing c. Side effect is f do reflect a change in c. F do make a change in c. And there is something called a code improvement. What is code improvement is the result of c. Like if I need to execute f of c. Okay, so uh, in this scenario, I am calculating c into d first. If I am calculating c into d first, if I am calculating c into d first, then if I am calling f of c after calculating c into d, only after calculating c into d, I am calculating f of c. That is only after calculating 5 into 7, that is 37, 35. Okay, I am calculating 35 first. Then only I am calling f of c. Then what I have to do? I have to store a. Yeah, already I need to store a. Need to store b. Not to store c. And also I have to store c into d somewhere in the stack. Since this is a function called whatever the values now, values that are using now, what are the variables we are using now, all will be stored in stack. So if I am executing f of c later, what happens is the value, the product of c into d also need to be stored. Okay, so here it says that the result of c into d need to be stored in another location, because since I am calling a function, whatever the current values are or current variables are, it need to be stored in a stack. So I need to find a place for c into d to store, to get stored. Okay, so that is a code improvement set. So ordering of expression do have two parts. That is side effect. That is the function may change the argument, and there is a code improvement in which the function will be called later, so that whatever the products or expression that is already evaluated need to get stored somewhere. Okay. Now next is something called a short circuit evaluation. What is a short circuit evaluation? Short circuit evaluation is you know that okay, so let's take this example. If A greater than B or C greater than D. Okay, we know that if there is something called an OR. Okay, this is an OR operator which is used to join two expressions, A greater than B and C greater than D. So A greater than B is an expression 1, C greater than D is expression 2, and E1 and E2 is joined using and operator OR. Okay, so we know that if E1 is true, whatever the value of E2 will let it be. If E1 is true, whatever the value of E2, we need know the result will be true because it is OR condition. Since it is an OR condition, then if E is true, you need not evaluate E2 because we know that whatever the value of E2 is, whatever the value of expression E2 is, it need not be evaluated. Instead, the resultant value will be since E or E2 is the expression. Okay. Likewise, if I'm using an AND condition, okay, if I'm using an AND operator, that I'm using an AND operator, okay, and if I am writing like E1 and E2, if I'm writing E1 and E2, okay, and I am evaluating E1, and I know that the result is false. The result is false. So I need not evaluate E2 because whatever the value of E2, the result always will be false. There is no dot on it. Okay, so if this is a short circuit evaluation. Okay, if the first expression is true, then need not evaluate the second one in this one. Likewise, if I am using an AND condition and operator, if the first one is false, then I need not go on with the other expressions. Okay, so what happens is this will reduce the complexity. This will reduce the complexity. This will reduce the computation power. Okay, need not execute E2, need not execute E3, whatever the and if it's a long line of and E1 and E2 and E3 and E4, and if I know that E1 is false, then I need not evaluate any other expressions. Okay, so this is called short circuit evaluation. Short circuit evaluation. Clear? Okay. Okay. Just this is another example or implementation of short circuit evaluation, and it is used to avoid out of bound scripts. Out of bound scripts. Okay. So what do you mean by out of bound scripts? Okay, that I am declaring an array of A of 10. Okay, I am declaring an array of A of 10. So the index will be from 0 to 9. Okay, and I need to check whether there is an element or there is a test value or there is a search value. I will be calling it search value. If I need to check whether this search value is present in this array or not. I need to check whether this search value is present in the array or not. Okay, so what I'll be doing is I'll be writing an expression like for I equal to 0, I less than 9, I plus plus, right? For I less than I equal to 0, I less than 9, I plus plus, and I'll be checking with if A of I equal to such. So this will be the program that I'll be using for I equal to 0, I less than 10. It's not 9, I less than 10, I plus plus. If A of I equal to such. So this will be the condition I will use. Okay. If I'm writing a for loop, I will be writing like a while. Okay, I will be writing while I less than 10. Initially, the value of I will be equal to 0 while I less than 10. And inside this for loop, I will be writing what if A of I equal to such. I will be writing so. If A of I equal to such, the condition will be written inside. Okay. Here, if this is a short circuit evaluation, if this language, in this language, if it uses short circuit evaluation, I can write it like while I less than 10 and a of I equal to such, sorry, equal to no, not equal to such. In the same step. Okay. If only if it is a short circuit evaluation, only if it is a short circuit evaluation, I can write like this. So the statement is like while I I less than 10, while I less than 10 and B of I not equal to such. So I am writing all this together. Okay. What happens if it is not short circuit evaluation? Let us check. Okay, if this is not short circuit evaluation, so if it is not short circuit evaluation, then even if this is false, the other step also will be checked. If it is not short circuit evaluation, if it is short circuit evaluation, since this is AND operator, if the first operation is false, then the second operation will not be evaluated. Okay, that is short circuit evaluation. Let this not be short circuit evaluation. Okay, let this not be a short circuit evaluation. So the condition is if I less than 10 and B of I not equal to such. Okay, so this is a condition. And I am compiling this one as if it is not a short circuit evaluation. Okay, so let this not be a short circuit evaluation. So what happens? For I equal to 0, body will be executed. I equal to 1, body will be executed. For I of 2, body of H will be executed. I of 3 executed, I of 4 executed, 5, 6, 7, 8, 9. It will be executed. And for I equal to 10, for I equal to 10. Okay, for I equal to 10. Sorry, the name of an array is A. Okay, for I equal to 10. For I equal to 10, what happens is it will check whether I less than 10. The condition is false. Since this is not short circuit evaluation, what happens? It won't stop with this. It will go and it will move to the next expression and it will evaluate. Right? So even if this is false, it will go to the next expression and it will evaluate. It will check whether A of I. What is A of I? A of 10. Right? A of 10. Okay. So A of 10. So what happens? A of 10. There is no index like A of 10. Since I am writing, I have declared it as A of 10. The indexes will be like 0 to 9. So there will be A of 0, A of 1, A of 2, up to A of 9. So there will be something called A of 10. So what happens? This will give an error, runtime error, since it is not short circuit evaluation. If it is short circuit evaluation, what happens? It will check whether I less than 10. The condition is false. So what happens? It will stop from by that. It won't go to the next expression and evaluate. Clear? So this advantage of short circuit evaluation can be used in some place. Okay, so that's what in this it is saying. Short circuit evaluation can also be used to avoid out of bound subscripts. Okay, here it is I greater than or equal to 0 and I less than max, and A of I. Here A of I is used like this, A of I. Okay, so if the value of I is lesser than 0, A of I will not be evaluated if this is short circuit evaluation. Likewise, if the value of I is greater than max, that is, this condition is false. If this condition is false, A of I will not be evaluated. Or if this condition is false, A of I will not be evaluated because it is short circuit evaluation. Okay, so that's all about short circuit evaluation. So short circuit evaluation deals with if one expression, if it is an OR operator, if the first expression is true, then it won't go and evaluate all the other expressions. Likewise, if the operator that is used is AND operator, and if we found that one of the expression is false, then it would not go and execute the or calculate the other expressions. Okay, so that is called short circuit.